Hey, this is group whiteboard problem 10.8. So we have a spring-loaded gun, launches a 10-gram plastic ball. So that is 0.010 kilograms. The spring has a constant, so K is 10 newtons per meter. It's compressed by 10 centimeters. That's my delta X, 10 centimeters or 0.1 meter. When the trigger is pulled, the spring is released and shoots the ball back. So what's the ball's speed as it leaves the barrel? Okay. Let's go to our ladybug. Okay, so I've started making our list of what we are given here. Okay, and we want a picture. So we have our gun, little toy gun here. And we have a spring that's compressed. Right? And then you fire the gun, and then the ball is going to exit with some speed here. Be final. Okay. Okay, so let's do our energy bar charts. Well, we want to find, actually, let's make sure we know that. We want to find V final. We have our energy bar charts. So initially we have energy stored in the spring, so that's U spring, initial. The other energy involved here is kinetic energy, initial. And then we will see what those look like at the ends, spring energy final. Here the spring has uncoiled, right, out to its original length. And then kinetic energy final. Okay, so initially all of our energy is in the spring. We have no kinetic energy. At the end, we have no spring energy, and all of our energy will be transferred into the kinetic energy of the ball that's getting launched. Okay, so this gives us our conservation of energy equation. So we bring this down here. We have 1/2 K delta X squared is the energy stored in the spring. This is going to be 0. Initial or spring energy after is 0, and so then we just have 1/2 mv final squared. Okay, this is what we want to solve for. So we do our algebra first. We multiply both sides by 2 and divide by m. So 2 over m, 2 over m. And we get k over m delta x squared is v final squared. And then take the square root of both sides. So v final is the square root of k over m times delta x. We have a spring constant now that we can plug in, so that's 10 newtons per meter. We are divided by the mass, 0.010 kilograms, and then multiplying by delta x, which is 0.10 meters. 10,000. Okay, so it's going to be the square root of 1,000. Bring up our Python window. So 10 divided by 0.01. Oops, forgot my period there. Times 0.1. So we get our final speed is 3.16 meters per second.